Hello students, in this particular lecture we will be going to study about that what is a schedule and what are the different types of schedules, that is a recoverable schedule, what is cascading rollback, what is cascadeless schedule, and what is the concept of serializability that we will discuss in the next lecture. Right, so let's start with this. A schedule is basically a set, you can say it's a set of n transactions t1 t2 to tn where the operations among these transactions are ordered in a certain manner. We have just seen in the earlier videos of transaction processing all those rectangular boxes where we have sometimes t1 t2, sometimes t1 3t. Those rectangular boxes are basically the schedule where we are executing a certain set of transactions, right? So a schedule S of n transaction t1 t2 to tn is an ordering of the operations of transaction subject to constraint that for each transaction who is participating in that particular schedule, the sequence of operations of ti in S must appear in the same order as in ti. What it means is, suppose the sequence is like this: I am reading an item X, I am updating some value to it, and then I am writing its value to the database. When that transaction is a part of schedule, then its operations should be in the same sequence. This is what a schedule is known as. Now let's start with this, that what is a recoverable schedule. A recoverable schedule is one where for each pair of transactions ti and tj, if the scenario is that tj reads a data item that was written by ti, the commit operation of ti should appear before the commit operation of tj. What it means is, suppose transaction, we have t1 and t2. Suppose transaction t1 writes a value of a data item x to the database, and then t2 reads that value. After the t1 has written the value of x, t2 reads its value, then the commit operation of transaction t1, it means transaction t1 should get committed before transaction t2 gets committed. If the scenario is like this, then we can say that our schedule is a recoverable schedule. I'll explain you this with the help of two examples. See this. Suppose I am having a schedule S1 and this is the sequence of operation. R1A means, R means the read operation, W means the write operation, 1 means that it is performed by transaction T1, 2 means that it is performed by transaction T2, and A means on the data item A, and B is the data item B. So when I arrange these operations, it will look like this. We have started, because first operation is performed by T1, it is, we have written under T1, then W1A, W1A, then T2. We cannot start R2A from here because R2A has occurred after W1A. It means T2 is reading the value of data item A after T1 has written it. That's why I have written R2A here, not there. Not there, I have written it here. Then we have R1B because it has occurred after this. Now, according to the definition of a recoverable schedule, here the scenario is that transaction T2 is reading a value of data item A that is written by transaction T1. It will be a recoverable schedule if T1 has committed before T2. But in this case, you can see T1 is still having an operation and it is committing at this point, and T2 has committed earlier at this point, immediately after R2A. So it means this is a non-recoverable schedule, right? Let's take an example. Suppose if T1 fails. If T1 fails while executing this R1B, but T2 has already committed, so that abortion, we have to abort the transaction T1. If it fails, then we have to forcefully abort the transaction T2. So it is not a recoverable schedule. Let's take another example. Suppose this, again we are given these set of operations. R1x means read operation performed by T1 on X, write operation performed by T1 on X, read operation performed by T2 on X, like this. So on, we have arranged it like this according to their sequence. Now you can see the commit operation of C1. C is denoting the commit operation. The commit operation of C1, although it has committed there, T2 is reading a value of data item X that T1 has written to the database, and the commit operation is T1 is before the commit operation of T2, so we will say that it is a recoverable schedule. Now the T2, because T1 has already committed, then there is no chance of its failure, so T2 will read a valid value of data item X. So this is a recoverable schedule. Now, what is cascading rollback? In a recoverable schedule, no committed transaction ever needs to be rolled back. However, cascading rollback may occur where an uncommitted transaction has to be rolled back because it reads an item from a transaction that failed. Cascading basically means back to back. Suppose I say we have three transactions. Transaction T3 is dependent on T2. Transaction T2 is dependent on T1. So in this case, because T3 is dependent on T2 and T2 is dependent on T1, T2 is reading a value that is written by T1, T3 is reading a value that is written by T2. So the failure of T1 will lead to the rollback of T2 and T3 as well, because they are the dependent transactions. So this is known as the cascading rollback, that the rollback of one transaction leads to the rollback of other dependent transactions as well, back to back. This is what cascading rollback is. Now you can see there, suppose this is an example. We have transaction T10, T11 and T12. T10 is performing this read on A, read on B, write on A. T1 is reading a value of data item A that is written by T10. T12 is reading a value of data item A that is written by T11. Suppose if T10 fails due to some reason before it is committed, if it fails, then it will lead to the rollback of T11 because T11 has read a value written by T10, and it will also lead to a rollback of T12 because T12 is dependent on T11. So in short, the failure of T10 will lead to the rollback of T11 and T12 as well. So this is known as the cascading rollback, that the failure of one transaction leads to the rollback of other dependent transactions as well. This is cascading rollback. Now, when we will say that it is a cascadeless schedule, that there will be no point of cascading rollback, there will be no cascading rollback, that is known as a cascadeless schedule. A cascadeless schedule is one where for each pair of transaction Ti and Tj, if Tj reads a data item written by Ti, the commit operation of Ti appears before read operation of Tj. Why we are saying this? If Tj is reading a value written by Ti and Ti has committed, if Ti has committed, then definitely there is no chance of its failure. And if it has committed successfully, then if now Tj is reading the value after the successful commit of Ti, if Tj is reading the value, then we need not to roll back the Tj because of Ti, right? So this is what cascadeless schedule is, because Ti has successfully committed and Tj is reading a consistent and valid value written by Ti, a committed transaction. So according to the definition, you can see this, that cascadeless schedule is a subset of your recoverable schedule. Every cascadeless schedule is a recoverable schedule, but every recoverable schedule is not a cascadeless schedule. Let's revise the definition of recoverable schedule and cascadeless schedule again. In case of recoverable schedule, if Tj is reading a value written by Ti, then commit operation of Ti should occur before commit operation of Tj. That is recoverable schedule. In case of cascadeless schedule, if Tj is reading an item written by Ti, then the commit operation of Ti should appear before the read operation of Tj, not the commit, before the read operation of Tj. So these are the two types of schedules. In the next lecture we will be starting about the concept of serializability and the two types of serializability, that is conflict serializability and view serializability. Thank you class.